Welcome to Day 2 video podcast on Simple Machines. How do you lift a lion? This book is by Robert E. Wells. Did you ever try to lift a lion? You'd have to be awfully strong. It's because of the force of gravity. Gravity pulls objects downward. When that object is as massive as a lion, it pulls pretty hard. With a lever, you can lift a heavy weight with much less effort. The main part of a lever is a bar or rod which balances or pivots on a fulcrum. If the force side is longer than the load side, you will have leverage. Leverage adds force to your own strength. With a force side this long, you could lift a lion. Now, do you suppose you could lift 10 lions? The longer the force side is compared to the load side, the more leverage you will have. So, if you had a lever with a handle this long, maybe you could lift them a little. Did you ever try to lift a panda on a pallet? It would be pretty hard. Gravity is pulling down on that panda, and there's also friction between the ground and the pallet. Friction or resistance happens when two surfaces rub together. The more weight pushing on the surfaces, the more friction there is. If you put wheels on your pallet, there would be less friction and you wouldn't have to pull quite so hard. Wagon wheels are mounted on axles. At the wheel center is a bearing which turns on the axle. A bearing's inside surface is smooth, so it makes very little friction. Oiling a bearing's inside surface makes it slippery, so it has even less friction. This is called lubrication. Wheels with bearings make much less friction than pallet bottoms. That's why you can pull the panda now, even though he's just as heavy. If you begin to go downhill, gravity takes over to pull your load. Gravity not only pulls objects straight down, it pulls them down slopes. So now that you don't have to pull, you could carry a much bigger load. Now you could carry a pyramid of pandas. And the steeper the slope, the faster gravity will make you go. If the slope began to get very steep, you'd probably wish you had more friction to slow you down. Did you ever try to deliver a big basket of bananas to a baboon birthday party? It would be mighty heavy. With pulleys, it would be much easier to lift. A pulley has a wheel with a groove around it to hold a rope. When you lift with one pulley, your lifting strength stays the same. But the direction of force is changed. With two pulleys, your lifting strength is doubled. You'll use twice as much rope, but you can also lift twice the load. Yes, pulleys make it much easier to deliver a big basket of bananas to a baboon birthday party. But perhaps a smaller basket would have been better. Our world is full of simple machines. The levers, wheels, and pulleys in this book are shown in just one of their many forms. Each of these simple machines comes in many sizes and shapes and can be used for many purposes. Yes, there are levers, wheels, and pulleys almost everywhere you look. Did you know that when you row a boat, the oars are actually levers? Likewise, a screwdriver is a lever when you use it to pry the lid off a paint can. And when you cut a piece of paper, your scissors are two levers working together. What would our lives be like without wheels? You'll find little ones on your skateboard, bigger ones on your bicycle, huge heavy ones on a train engine, and tiny ones inside some watches. There are other forms of wheels you might not even recognize, like the doorknob you turn to open your door, or the faucet that turns off your water. Pulleys pull you up in elevators and ski lifts. They help raise sails on sailboats and flags up flagpoles. With pulleys, a window washer can lift himself or herself right up the side of a skyscraper. Look around your world and you'll discover more examples of levers, wheels, and pulleys. How many can you identify? It was a very good book by Robert E. Wells, How Do You Lift a Lion? Okay, boys and girls, this week we're going to be exploring different simple machines as we learned yesterday. I'm going to show you some examples and some of the trade books that I have in the classroom for you to use when you are researching your project and working on your PowerPoint, which we will discuss a little bit later. First is a book about levers written by Michael Dahl. And I have some examples of levers. Remember, How Do You Lift a Lion? The book mentions scissors. And I also have this little, it's a little paper holder, and if you look, it has a fulcrum in the middle because I'm mashing it to be able to pry it open, and then it holds the papers tightly. Here is a book by Ann Welsbacher called Screws, and if you look, you will see my screw example. Now, next I'm slicing butter with a knife, and a knife acts like a wedge. This is a book called Wedges, also by Ann Welsbacher. My next example, Wheels and Axles. I have this little tiny red wagon that I have had for years when my children were younger, and it happens to have a very loose wheel, so you can see what it's talking about, how wheels and axles move. I can get this one to come off. Maybe it's going to stay on now. Nope, there it is. Okay, you see the rod that goes through the center of the wheel. This is the axle, and this round part is the wheel, of course. Okay, next, pulleys. This is a book also written by Michael Dahl. And then I have a couple of books that are just entitled Simple Machines, and they have to do with different experiments that we are going to be looking at also in our study of simple machines these next 2 weeks. And the last example, I have an inclined plane, and I will back up so you can see it. This book entitled Inclined Planes is written by Michael Dahl. Okay, there you have it, our 6 simple machines. We'll have lots of fun these next 2 weeks as we explore the simple machines and where we can find them, how they're used. So I hope you will enjoy our study of simple machines.